morning, I'm David Lievesley from Universal Robots Technical Support, and today I want to answer a question that sometimes we get asked is how can we add additional safety onto the robot? So let's say, for example, we have an application where we need to run above collaborative speeds, but people might still be in an area where they need to come into contact with the robot, so we need to slow that down. So of course we have the safety system on the robot, which has 17 category 3 performance level D safety functions, but we can also add additional safety in. And a cool device that we've got is the 6 safety scanner. So what's cool about this is the software for the scanner to enable us to set it up and change the settings actually sits on the teach pendant. So this is really good if we need to move the robot around from location to location. We don't necessarily need a laptop to set it up. We can actually set everything up from the teach pendant. So just to show you how that works, so this is a teach pendant from the Universal Robot, and I've loaded the UR cap for the 6 safety scanner. So I'm going to go into installations, UR caps, and now I'm going to select the nano scan, which is a 6 safety scanner. It just actually connects to the scanner, so it does some checks before it allows me to action it. Perfect. So now I can go into the settings of the scanner. So I click on settings, and now I've preset my password. So on this robot, it's UR safe. So it's exactly the same as the safety settings. So I say OK to that, and then I'll log in. What's nice now is I can see the scanner settings, so I can see the robot, the base, and of course the zones that I'm going to slow the robot down or stop the robot. Perfect. So now the first thing I can do is set the desk up. So the desk on my particular setup is the Easy Robotics stand. So I've set the dimensions of that stand, and here you can see that in grey. I then can click onto the robot, and now I can set the origins at the center point of the robot. And now we can set the fields. So here we can see the reduced field, so I can set it at 1500 millimeters, and then the stock field I've got at 100 millimeters, should I say. So let's say I wanted to change that. So let's say I go to 200 millimeters. Perfect. Then I'd apply that setting. So I've changed the safety settings. So I apply that and I say OK. So now the system asks me to verify that safety change. So I just verify that. It gives me green ticks. And what's really cool now is, in a second, it actually gives me a configuration settings report. So I could actually take a screenshot of that if I want. So if we cursor down, we can see all my settings. So these are the reduced mode, the stock field, and then we can see the parameters that's actually set. So for your risk assessment, once you'd set the safety scanner, you could take a screenshot of these settings, print it off and put it into your safety folder of your actual risk assessment. Perfect. So now I can verify that and OK that, and then now I need to log out. So again, it connects to the robot, and now I can say next, and now I've actually got the functional screen where I can add, basically I could ignore fields. So if I press teach, in this particular area it's quite a condensed area, so you'll see the scanner is actually going to scan, but it's going to find obviously our training benches, so it's a little bit condensed, and we're going to show you an example. So here we can see the 2 training benches, so that's the scanning field of the robot. So just to let you know, if I wanted to ignore certain parameters, I can click on walls, and I can just draw on the teach pendant and draw across there. In a second, let's try that again. Perfect. So now I'm actually ignoring that side of the wall, and then of course I could add myself another wall if I so wish. So as you can see, it's completely customizable how we want it to ignore particular areas. So if you've got an area that was particularly busy and you didn't want the scanner being activated, we could just activate a wall and reduce that issue. Perfect. Then I'd press next and log out. So it's you are safe, and say yes. Oops, sorry, password not valid. You are safe. Say yes. Perfect. Once you've done this, those settings have to be updated to the scanner. So at this point, the scanner hasn't been changed. We've only changed it on the actual teach pendant. So it just takes a couple of seconds to actually activate that and then you'll see the status bar go across, and then the scanner is actually changed with those settings. Okay, so now we've uploaded those safety settings to the robot. We've now brought it out into a more open area so we can see the scanner working. So if we look at the front of the scanner, we have a green tick. If I approach the scanner, it then activates because it's detected me. So now we can show you it actually working with the robot. Okay, so now we've set the robot going, so it's going at a speed that is non-collaborative. So the scanner is active, so if I walk in front of the robot, it now slows it down to that reduced mode that I've actually set in our safety settings. So we can alter how slow we want the robot to go in our safety settings. Okay, thanks for watching. Next week we'll come back with another UR Plus product.
We're Daften Diecast. We're based on the Camel Estuary down in Weybridge, Cornwall. We're an ISO 9001 company, and we're also proud to be part of Make UK and Made in Britain. We mainly focus on high pressure aluminium die casting. We initially started looking at robots maybe 4 years ago. We had a very distinct product with one of our larger customers. We then got in contact with yourselves at Applied Automation, and we started looking at universal robots. Through collaboration, we ended up with the UR5E robot with an orbital sander from Dynabrade on it. Since implementing the orbital sander, it has boosted production 600%. With the sanding process being automated, it allows the product coming off the robots to be of a higher quality. So when we go to paint the castings, there's more consistency in the finish that we can achieve. Once I got hands-on with the robot, it's a very simple thing to program. Our second Cobot cell is also being used for sanding. It was another monotonous job that operators didn't really enjoy doing. It's also greatly reduced the amount of vibration that the operator is exposed to just touching up the casting. That's all they really have to do afterwards, which is beneficial.
Hi, welcome back to the Cobot channel. This week we're joined by Dan Tyas, who's a senior engineer for Olympus Technologies. Hi Dan.
Hi Mark.
How are you?
I'm good, thank you.
Good. Can you tell us a little bit about your role at Olympus and what Olympus Technologies do?
So I'm a senior project engineer. Olympus Technologies is an integrator of robotics, primarily cobots these days, across any industry you can imagine.
Okay. And one of the things we're going to discuss today is how cobots are being used in welding. And how are they different to industrial robots in this application? What are sort of main benefits of cobot welders over industrial robot welders?
The primary difference I would say is ease of programming and also ease of implementation. Historically, if you look at an industrial system, it might take us 2 or 3 weeks to integrate, whereas within as short a time as a day, we can actually be welding with a cobot.
So you can actually get something delivered, and then by the end of that day, you can be up and producing, I guess.
Yeah, so we usually arc on within a day. And then as a company, we usually take a second day to support the customer.
Okay. And is that quite a small footprint, the cobot welder? Is that something different to what a big industrial welder we would normally associate with having guards around it? So.
Certainly, yeah. I mean, a much smaller footprint. We can operate on mobile stands, but actually 99% of the time we're on sort of a small column stand, and then the customer could even use their existing tables either side of it.
Oh, so they don't have to make big changes to their existing fixturing then?
Not necessarily. We can sometimes work with existing jigs, existing booths. It really depends on sort of accuracies.
Okay. And one of the main advantages of cobot welding is all about increasing productivity. Can you tell us a little bit more about that, how much it can increase?
So as we've worked with different customers, we've actually seen 3 to 4 times, sort of productivity increase with single shifts. This is using break times and other times that a welder might be distracted from his work.
So one of the main advantages of cobot welding is increasing productivity. Can you tell us a little bit more about how you can increase that?
Yeah, so typically on an average cobot welding cell, we see 3 to 4 times productivity. And this is usually just gained by sort of gaining back breaks and lunch times, things like that.
So that 4 times productivity, that's measured like on arc-on time. It's how much weld they're doing in an hour as opposed to a man doing it, I guess.
So yeah, we have metric systems that gather that data, and you can look at arc-on, or even you can look at something as simple as parts through the door.
Well, I guess it's similar to machine tending. They say if the spindle's turning, then we're earning it. So I guess if it's arc-on, then they're producing more.
Exactly.
Yeah. typically, how does a Cobot welding system work? Because we've seen welding sources and we've seen Cobots, but they just don't connect together. So what's kind of unique that makes it work?
So the power source will have a robot interface. There tends to be two types of this, a wide interface or an Ethernet-based interface. We tend to use an Ethernet-based interface, and that's coupled with a UR-CAP, piece of software written to go bring the two together.
And that coordinates the welding source with the robot?
Yeah, so depending on your software package and your power source, you can take varying control of the power source, but we tend to take parameter sets and weld speeds, things like that, and program them directly into the robot.
And how would you use that cap to set up a weld then? Is that something like a recording, a pathway, or is it something you would draw onto, you know, the workpiece that you want to use the robot for?
So it's waypoint-based programming. You set start, you set end, you set a parameter set, and off you go.
Right, it's as simple as that then?
Yep, drag and drop.
Okay. And by using Cobots, it's possible to fill a skills gap. We hear a lot about there's a lack of skilled welders in the industry. How quick can that be implemented? If somebody's got a welding shortage now, they've got welders that they've got going to retire in the next sort of 6 months, how quick can they get a Cobot welder in to come and help them fill that gap, if you like?
So we tend to do 2 days training, and that would be at our facility. And then there's 2 days install. The first day would be physical, practical install with some calibration. Then we spend the second day of the install getting them into production.
Okay.
And usually as quick as that, they can actually be producing parts.
And who would you be training? Is that existing welders, or is that other people? And do they need to employ a special engineer for that, or is it?
2 methodologies usually used. Either we teach the welder that exists at the company. There are advantages to that. He knows welding, he knows the power source. But a lot of companies now are actually taking people out the offices, CAD guys or CNC guys, and they'll program the robot with the support of an existing welder for parameter sets.
Excellent. So that's actually creating maybe another job or another skill set for somebody else.
Correct.
That didn't exist before. And we're seeing more people acquiring these new skills. Is that something that you're seeing as well, that Cobot welders are actually, you know, people who are existing welders are taking on the programming of the Cobots as well as a part of their skill set?
Yep. Upskilling is a constant thing we do with welders, but we've also seen that companies are able to have more interest from apprentices and from some younger members of staff because it's a robot. You know, we're seeing now that maybe people don't want to sit in a welding booth like they once did, but they will come and program a robot. So there's a bit of interest there.
So that's really interesting, isn't it? Getting younger people into engineering, because that's something that we want to do. And one of the things is, what type of company does this sort of solution suit? I mean, is it only large companies or multiple manufacturers, or is it suitable for smaller companies who do smaller batch runs?
We've got robots now from small batch SMEs up to sort of conglomerate global companies. Because if you're taking a productivity increase of 3 to 4 times, you've got a payback, whether you are a small company or a large company. Your return on investment is excellent for either side.
Yeah. And SMEs, I guess, it's quite acute for them, that problem. If they've only got 5 welders and one of the guys retires or leaves, then the gains for them is much bigger than a larger company, I guess.
Yep, absolutely. In your SME market that's trying to hold on to welders are having to pay more and more in wages, when actually conglomerate companies can obviously afford to pay that, so that it's actually increased, that problem is increased with SMEs.
Yeah. How are collaborative welding cells being received by the workers, the people on the shop floor? Are they generally quite open to that, or are they seeing that as we discussed, maybe like an expansion of their skill set?
So what we work with companies to sort of bring a culture into a firm, because usually the welders like it, because you're taking away jig work, you're taking away repetitive, boring tasks, and allowing them to do larger fabrications and more interesting work.
Yes.
And if that's sort of communicated to them, then usually they're on board.
Yeah, I mean, that's one of the main advantages, that you can let the robots do the tedious stuff, the fiddly stuff, and let the guys really use their skill. And let's be honest, I mean, human skill is the most valuable asset for any manufacturing business, and in welding, that's the asset that you're making the money out of, aren't you? Using welders to produce products. And what sort of advantages can Cobot welding bring to quality of products as well, compared to a welder that's got a skill set who's been a welder for 40 years? What sort of advantages can they bring?
Sure, that welder will always be the man that sets the power source and really understands the weld, but robots have steady hands.
Yeah.
They move very continuously at a set speed, and those 2 parameters lead to quality increase in welding.
Yeah. And I guess it's like holding something at a critical angle, and also they don't get tired, or
Yep.
they can produce a better weld.
Yeah.
And the advantage of that, I guess, is if you're making a better weld, then there's less time spent trying to dress that weld up, and
Yep.
using vibratory tools as well.
Using modern welding techniques like pulse welding, you can usually completely eliminate spatter, which historically would have been a dress down process, which can actually take longer than the weld itself.
Mm-hmm.
And then, yes, now HSE is so interested in vibrationary tools that taking grinders and things like that out of workers' hands is just another win.
And one of the things, if people are implementing this technology and it's reducing their overheads, how can that impact their business then? Is that, have you seen anecdotally advantages to people who've put Cobot welders in?
Taking on a smaller batch work and sort of be more competitive on pitch. So a smaller company can actually be more competitive, gain a contract they might not have been able to take on before because of margins and overheads. If you can take a job and do it much quicker, you can naturally charge less for it and then get more product out the door.
And that's making them a bit more sustainable, I guess, isn't it, in the current climate, is that you know what your costs are going to be, you're going to fix them, aren't you?
And actually the investment in modern welding technology saves you a lot of electricity. Modern power sources are multiple tens of percents more sort of efficient than old school step transformers.
Yes. Okay. And Olympus has got another side to your business. You don't only do welding. What kind of other applications do you specialise in?
So a big growth market for us is machine tending and press brake tending. We have a couple of companies which we've worked with for years now, and they have dozens of systems in. And also the food and beverage market is something that's come up in a big way. Co-packing, palletizing, depalletizing, all huge growth markets.
And I guess they're facing the same issue, is it? A lack of labour and wanting to increase productivity.
Yep, labour and productivity, exactly.
And you touched on CNC tending there. How, what sort of main advantages are using Cobots for that that you found from your customer base?
Absolutely, it's very similar to welding. I mean, if you think about your breaks, your lunch times, and also a potential lights out. We have a company at the moment that has a 45-minute cycle on a billet. Well, you don't need many billets to have a night shift. They can actually leave it running for 7 hours, and at the time they've got, no expedited costs for nighttime work.
So you've got extra capacity out of an existing machine as well, I guess. So
yeah.
You're actually getting more value out of your process as well.
Yeah.
And is that true of the sort of packaging side as well, that you're seeing that? Is it just to replace labour, or are there productivity gains with the packaging side as well?
Usually productivity gains. Palletizing is usually, you can time a man or time a person or time a team, and box for box they might be quicker. But I said over the shift, you've got huge gains because of the continuous work.
Yeah, Cobots don't go to the toilet or take a tea break, do they? That's the big thing.
No.
It's quite interesting that you mentioned that, because when we looked at this before, if you've got an 8-hour shift, there's usually an hour lost for breaks and people starting shift and people going off. And if you've got a robot working throughout that 8-hour shift, it's working for the full 8 hours, isn't it? And that sort of capacity, that soon adds up over 300 working days a year. It's quite significant how many more products you can make, I guess.
It's huge.
Yeah. One of the things that you touched on there about you go and when you see companies about implementing this technology and you get them to adopt it as a culture change, if you like. Once a robot's been installed into a company, do they start to look for other areas where they can automate, or is that just the first thing? You think about that as a solution for my first part of the process, and they're happy with that. Do they tend to look for other applications once one's been installed, or do you have to push them down that route?
Usually they begin to see the potential of the system, they see it working, but also culturally, people begin to sort of look round for the management staff as well and even bring ideas to them.
Yes.
Usually jobs they don't want to do.
Yes.
Unpleasant jobs, repetitive jobs, difficult jobs. They've seen that nobody's lost the job.
Yes.
Because it's implemented, it's working, and no one's been made redundant. So usually you get sort of more of a...
They're more open to it, let's
absolutely,
say. Yeah. It's one thing that we also touch on as well when we talk to companies is, we ask them to get their employees to buy into this and actually nominate the jobs that they wouldn't want to do. And let's face it, there's some terrible jobs out there. You stood all day grinding welds or linishing parts and stuff like that. We shouldn't really be employing people to do that nowadays. We should be able to provide a solution where we can use that person somewhere else, I guess. It's interesting you're seeing the same thing. What's the most interesting application that you've seen out of all the ones that you've done at Olympus, do you think?
Well, we've done so many now. One of the most recent ones we've done that was very enjoyable was actually press brake tending. It doesn't sound like a hugely interesting one, but it worked so well and the productivity went up. The company was so happy. There was cultural adoption. every tick box for every automation.
Yes.
That for us, and the, you know, sort of the interest from other companies now on the back of that's just been huge. It's
a really good thing, isn't it? If you put something in and they really buy into the culture of it, then it makes it so much easier for other people to see the advantage and so on, I suppose. It's right. It's an interesting point. Are there any sort of future developments that Olympus are working on? I know you talked before about collation cells and so on for repacking, but is there any new sort of projects and things like that that you're working on, or new products that you're working on that you want to discuss?
So we're looking more and more at UR caps. This is software to make programming the universal robot easier.
Yep.
And on the back of the press brake tendon, we're looking at a press brake tendon cap.
Okay.
And collation caps. All this, we now have a software development team to really take those what can be more complex jobs and streamline them into productivity.
And people will be able to download that cap onto a robot and then be able to set that up for that particular application. Just make it easier, basically.
Yeah.
Excellent. All right, Dan, thanks for joining us today. Join us again next week when we'll have another interesting guest from the world of robotics.